Hi guys, welcome to Minecraft, and this is Flandyn, and this day's tutorial is going to be RAM. As I did last time, I will build or show you a huge RAM design to show you how it works, and then I'm going to do the small one. I'm just mentioning it right now that the small one is actually Batmanbugs' design. It's the best I've seen, and please check out his videos, they are awesome. And because it is his RAM, I will build it in orange because it's his favorite color. Okay, starting with the huge design. So when I'm building RAM, I'm usually doing the bud switches. They are very helpful when it comes to RAM. Very handy. This one will also be non-stackable, so I don't recommend you to build it just to see how it works. That's probably the only use it has. Especially when you see the other design I have. Okay. So here we go. Here is our write. Here is our user input. And now we need to get the read signal. So the first thing we need to do is to invert this. And I'm just keep building. Like, my rule for this is that there is kind of almost two one, let me see, it's a one AND gate. The read is an AND gate, while this is a D flip-flop, basically. So let me think in a moment right now. Okay, I did a minor mistake, so bear with me please. Okay, so basically we need to do this. This is not a bud, or is it? Yep, this is a bud. As you can see, torch is off, which is kind of not good, but I can do it like this too. And here is our read. Okay, so good as that. Okay, this block or this piston will not get activated and give 1 for the output before the read is on and the D flip-flop is activated. Right now it's off, of course. When you give the user input, then you can write the signal, then you can read the signal, and there's the output. And you may wonder if this will be like very huge, but this is like, it's a normal RAM, and RAM needs to have the write and the read, or everything will get more confusing. It's like in 1 bit there's no point, but in 8 byte, like that one over there, you will need it. So this was the big RAM. As you can see, it's very simple to understand. The AND gate here and the D flip-flop here. I inverted it a couple of times to get it right. Just turning it off right now, and right. Okay, so that's how it majorly work. So I'm doing far up here because a 2x2 is very, like, it's very long, or tall, I mean, sorry. Oh, long. Well, that's hilarious. So right now I'm building the D flip-flop. As you can see, it still uses this bud switch. I'm using piston here, and I'm still going to show you how this one is made. Okay, so here we have our deep flip-flop. It's looks maybe way small for you. Here is our read, user inputs, and here is our writes. And when we have these two, we can start with our read. Okay, so let me just move on. And there we have the input. And then we're making our second kind of read thingy. Jag vet inte vad jag ska göra. Well, yeah, just moving on. So here's our read, here's our write, and here's our user input. And just to show you where to place the outputs, it's very important to have the input and output on the same lines, and have the read and the write on the same line. So as you can see, here is our line, and to gain inputs we're doing it like the same way as we did on top here. Here you can place the lever here, and there is our 2x2 RAM, Batmanbugs design, just telling you again. And I could stack it, but this, I can promise you that this is 2x2 stackable this way, this way, this way, and this way. Oops. And thank you for watching. Next time I'm going to show you about alias and shifters. So bye. On the same lines, and have the reads and the write on the same lines. So moving on, then we can start with our outputs, and to gain inputs I can just show you this. Okay, so this one will always be on, and this line will always be off in case but it will gain input if the piston will get retracted. The piston will get retracted when this piston will gain input, and it will only gain input if the flip or the D latch is gaining input, and the read is off. So that's it for the RAM, guys. Right now I'm going to work on showing you shift registering. I'm going to show you the monostable one. If I remember the timing, it's pretty hard to remember. It's something quite hard. And for this I'm also going to do stack, because it's kind of annoying if you're not sure about the timing. I think it's like 3 here. 1, 2, 3, and here's the piston going up, and here is our 2 piston lines. I'm going to make a monostub circuit, but I'm kind of a bit basic. This works also just as a monostub circuit. It will give 1 pulse. But that doesn't help me, so I need to build one. Okay, so just keep going. This one is probably one of the bad design how to make a monostable circuit, but I kind of like it. Okay, so let's test it. Okay, and for this I'm going to use some Wallet because it takes such a long time to make everything. copy, paste, and now we are doing the stack here. Need to grab some redstone too. So we need to stack it to like, I don't know, like 7 should keep it. Okay. So I want to test this. I'm giving it some inputs. And shifting basically can give the input, move every input to the right or to the left. Like, I need to see if I'm doing this correctly now. Yes? As you can see, it works this way. Okay. What about this one? I'm a bit more afraid of this one. Yes, as you can see, the input is slightly wrong. And it just duplicated, which is not good. So I'm giving it 2 more inputs to try it. And there it works. So now we can move the inputs from the left to right. This is called shift registering, left and right. There's other ways to do it. You can do it the manual way, just while wiring. Just to go like this. There's also one more method, but I'm not going to show it. It's something simple, you could figure it on your own. And thank you for watching. Please comment, ask me whatever you want. Please subscribe and like the video. This was Flandyn, and bye.